In this week's activity, I'm going to have you use an app that I created that simulates the process of taking a random sample from a population and creating a confidence interval. I actually created this using a program called Axure, which creates prototypes of apps. A prototype is just uh, kind of a rough version of an app that just so that the app can be tested. And let me explain how this works. So here we have a population. It could be any population, like let's say a city or a university, and the mean of the population has been set to some number, but the screen doesn't tell you what it is. It's unknown. And what you can do is take a sample, a random sample of 5 people from this population, and well, first of all, this is actually the mean age of the population, which is something that you would like to know. Well, I'm having you imagine that it's something that you would like to know. And when you click Take Sample, you get a random sample of 5 people from this population, and it records their 5 ages. Then what you do is you press Calculate, and it'll calculate the mean of your sample by adding the 5 ages and dividing by 5. You'll also get the standard deviation of your sample and the standard error. Then what you do is you go up here and you select your confidence level. So let's say I pick 95%. That's what people usually choose in real life when they create confidence intervals. After I click 95 and I select my confidence level, I can calculate my margin of error. So I'm going to press calculate. Now what I do is I can take my sample mean, the mean of the 5 people, and add and subtract the margin of error to get my confidence interval. So the way I've designed this is you can actually click on the mean of the sample right here, and it'll put it in right here. Then you click on the margin of error, and it'll put it in right there in both boxes. Then click this equal sign, and it'll subtract. And then click this equal sign, and it'll add the margin of error. And then check your answer, and if you clicked the right boxes, it'll be correct. Now this says, how confident are you that the mean of the population, the question mark, is inside of this interval between these two numbers that you just calculated? And if you set the confidence level to 95%, then you're 95% confident. So I'm gonna type in 95% and check my answer, and it's correct. Now what we could do is actually show the mean of the population, which is something you can't do in real life, but in this simulation you can do it. So I'm going to click Show Population Mean, and the mean age of the entire population is 35, and that's actually not inside of my interval because 35 is above 34.59. So the population mean is actually above the upper end of my interval. So down here, for this last question, I'm going to say that the population mean is above the interval, and that's correct in this case. Now, if I want to do this again, I refresh. And when I refresh, it resets everything, and now it's like I'm taking a new sample from a new population. So now I have a new population that I'm studying, and once again, the mean age of the population is unknown. And again, I would like to know what it equals. I would like to estimate it. So I do it over again. I take a random sample, and I go through the process. And each time you reset it, it's like you're doing a new study. It's like you're studying a new population, and you want to know what the mean age of the population is, and you take a random sample, you create a confidence interval, and you say, I have a certain level of confidence that the population mean is inside my interval. And in this simulation, you can actually check if the population mean is inside the interval, but that's something you can't do in real life In real life, you just create the confidence interval and you say how confident you are, and you just hope that the population mean was captured inside of the interval. And and this is, like I said, this is what you'll be using for this week's activity.